Hey, LogicSolver. Thanks for getting back to me. I've been slacking a bit as well. Last couple weeks of school were pretty hectic. But yeah, thanks for your response. I wanted to say that yes, my theory is two-dimensional in a sense, except that the x-axis and the y-axis don't behave in the same way. The x-axis can be seen the same as a one-dimensional timeline, the way that you describe it. The y-axis is a series of those timelines. So while the x-axis is fluid, the y-axis is separated and can be described using regular integers. That's only a basic description of it, but that's how it would look if you were to map it out, I guess. I wanted to state that my theory doesn't require that the y-axis be more than one line tall, so it still allows for the possibility that time is one-dimensional. If there, it's yeah, it's. I'm saying that it's possible that random events can occur, but not necessary. My theory of time still encapsulates the possibility that there are no random events, in which case it would just be a single line with no elevation on the y-axis. Um, and that's why I say that it's similar to a one-dimensional deterministic point of view, but different, because all the temporal instances in my theory work the same way as one-dimensional deterministic timeline. The only difference is that my theory allows for a single universe to contain multiple instances. Now, why I say that time travel is possible is because one-dimensional time travel is still possible. The current leading theories of one-dimensional time support one-dimensional time travel. It's just such that you couldn't change the past. So you could go back in time and meet your past self, but only if you had met your future self in your personal past. And you could do nothing that would prevent your past self from going back in time, because you didn't prevent yourself from going back in time. Because one-dimensional time theory states that time is deterministic, so your future is set just as much as your past is. So you can't change your past any more than you can change your future. But that doesn't mean that the events don't occur. Now, on to what you were saying about space-time being made up of points. And when I refer to points, I'm talking about points as they're described by Euclidean geometry. So they have no length, height, or depth, or in the case of time, simply no length. Now, the basic refutation of the idea that what you're talking about, a line as an infinite series of points, is that an infinite amount of the number 0 all added up still amounts to a total of 0. So any amount of points put together will equal the same amount of space as a single point, which is to say none. Points can only be used in relation to measurements that occur between them, and as such are methods of relative description. In other words, all points in a space-time that you describe are arbitrary and dependent on the describer. They're not intrinsic properties of the universe, which is because they don't describe actual locations. It's because they do describe actual locations, and actual locations are not non-existent the way that points are. So a line can still hold within it an infinite number of points, but it can't be made up of those points, because the points can only describe it. They can't describe a single point itself can't describe anything within the line. You can only describe parts of the line between 2 points. And that's partly where my theory differs, because yes, we describe time as being two-dimensional in a sense, except that the transitions on the y-axis aren't smooth, and so points can be used in the case of temporal instances, because they do describe locations which are non-existent, moments where a causal chain does not exist, which are as close as possible to a causal chain which does exist without being within that chain. And that's why I say that my theory of time is two-dimensional in a sense, because if you were to draw it out properly, the y-axis would always equal 0. because the only thing that marks the height is a series of points, and so in reality it would look more like a single constantly changing line. Now, you say that space-time is but a single point along a would-be other dimension. So for the reasons that I stated above, I'm just going to go with the idea that single points are non-existent because that's how Euclid uses them. So yeah, they only make sense by describing what's between them. So instead of just say that time is a distance between 2 points, which makes the distance between 2 points consistent with the definition of a complete set. So if, for argument's sake, actual infinites are possible, then there should still be no problem there. And then we can still put 2 more points within that set and change what happens between them. We don't need to pull up a second dimension in reality because the events that took place before the change occurred would no longer exist, and so if we were mapping reality, then we wouldn't need to include them. But still, from our point of view, the change would take place at the same rate as the original events did. So our past changing would not change our present until after our present is over. So the second dimension is still a would-be dimension, which doesn't describe reality, it only describes our perception of it.